Today, we're going to pull on a cosmic thread, one that asks a question that sounds simple, but trust me, it unravels the whole story of the universe. Could a star exist all by itself, completely without a galaxy? The answer might just change how you look at the night sky. Just try to picture it for a second. A single point of light, kind of like our own sun, but it's totally adrift in that mind-bendingly huge, crushing emptiness between galaxies. We're talking millions of light years from anything you could call a neighborhood. Is that even possible?
Well, the answer, incredibly, is yes. The universe is absolutely teeming with billions of these stellar castaways. But, and this is a really big but, their story isn't so simple. You see, the fact that they exist is one thing, but how they got there, well, that reveals this deep, profound connection between stars and the galaxies we assumed were their only possible homes.
To really get to the bottom of this, we have to split our main question into two totally different ideas. See, it's not just about whether a star can be alone, but also whether a star can be born alone. And those are two very different things. So here's our game plan. First question. Can stars actually exist outside of a galaxy? As we just found out, the answer is a definite yes. But the second question, that's the real puzzle. Can they actually form out there, in the middle of nowhere? Now that's where it gets complicated. So let's start with the evidence. How do we even know they're out there?
So yeah, how do we know these rogue stars are a real thing? This isn't just some wild theory. Astronomers have literally been hunting for these cosmic ghosts for decades.
The first big clue is something with a cool name. Intra-cluster light. Basically, when we point our telescopes at these massive clusters of galaxies, we see this super faint, almost ghostly glow filling the space between them. And that glow? It's not space dust. It's the combined light of billions upon billions of homeless stars. And we're not talking about a small number here. In some of these packed galaxy clusters, these stellar runaways can account for a shocking 10 to 20% of the total mass of all the stars in the cluster. That's like 1 in every 5 stars just wandering around without a galaxy to call home. It's wild. You know, this whole idea has a pretty cool backstory. Scientists predicted this light should exist way back in the 1950s, just based on their theories about how galaxies crash into each other. But it wasn't until 1997 that the Hubble Space Telescope was finally powerful enough to actually see it, to resolve that faint haze into what it really was, individual little points of light, lonely stars in the Virgo cluster. Okay, so we've established they're out there, billions of them. The next obvious question is, how? How does a star get evicted from its home? The answer, as you might guess, involves some of the most powerful and violent events the universe can cook up. It really boils down to 3 main ways a star can go rogue. First, you have galactic mergers. When 2 galaxies collide, the gravitational chaos can literally rip stars away and just fling them out into space. Second, the black hole slingshot. A star gets a little too close to the supermassive black hole at the center of its galaxy, and boom, it gets shot out like a pebble. And third, a supernova kick. If a star is in a pair and its partner explodes, the force of that blast can kick the surviving star right out of the galaxy.
And listen, we are talking about unbelievable speeds. The forces at play here are so huge they can launch a star at over 1 million miles an hour. This is not a gentle drift into the sunset. This is a violent, high-speed eviction.
And we've seen this with our own eyes, so to speak, right here in our galactic backyard. Astronomers found a star called S5-HVS1 that's just screaming out of the Milky Way at over 1,700 kilometers per second. You can just imagine it, can't you? A star violently thrown from its home, destined for a very, very lonely existence in the void.
All right, so we've nailed down that stars can absolutely exist alone. But now, let's get to that second, trickier question. Can they be born alone? And this gets to the very heart of what it takes to build a star from absolutely nothing.
Think of it like a tale of 2 cradles. Inside a galaxy, you've got the perfect stellar nursery. You've got these dense, cold clouds of gas, full of heavy elements from older stars, everything you need to get the process started. But the intergalactic void, it's the exact opposite. The gas out there is incredibly thin, it's hot, and it's super spread out. So here's the bottom line. For gravity to work its magic and pull stuff together to make a star, that stuff needs to be relatively close to begin with. In the huge, empty space between galaxies, the gas is just way too spread out. It'll just float apart instead of collapsing. So, in the universe as it is today, making a star out there is basically impossible. But notice I said in the universe as it is today. Impossible today doesn't mean it was always impossible. To find an exception to this rule, we have to turn back the clock way, way back to the cosmic dawn, when the very first stars were just starting to light up the darkness.
So, let me introduce you to what we call population 3 stars. These were the pioneers, the very first generation of stars in the entire universe. And they were nothing like the stars we see today. They were made of pure hydrogen and helium, they were absolutely enormous, and they lived incredibly short, violent lives.
Now here's the twist. These first stars didn't form in giant, sprawling galaxies like ours. They formed in these much smaller, denser clumps of dark matter and gas called mini-halos. You can think of them as the tiny seeds that would eventually grow into the first galaxies. So, whether you want to call them galaxies or not, the point is the same. Even the very first stars needed some kind of gravitational nest to be born in.
Okay, let's pull all these threads together. We've got modern-day exiles, and we've got this primordial exception from the dawn of time. So what does this all mean for these lonely lights in the void? We can pretty much sort all these homeless stars into 3 main groups. First, you have the exiles. These are the ones we've actually seen, born in a galaxy and then kicked out. Then you have the true orphans, which are still just a theory, stars that might, maybe, form in dense streams of gas between galaxies. And finally, the primordial survivors, ancient relics from those very first mini-halos that have long since faded away.
What you end up with is this really beautiful story of cosmic interdependence. Stars are what light up the galaxies, but the galaxies are the nurseries. They provide the raw materials and the right conditions for stars to even be born in the first place. One really can't get going without the other.
And that leads to this really powerful conclusion. Isolated stars are cosmic dead ends. Think about it. A lonely star will live its life and eventually die. But when it does, all those crucial elements it forged, the carbon, the oxygen, the iron needed for planets and for life, they just get scattered into the void, lost forever. Inside a galaxy, those same elements get recycled into new stars and new planets. A galaxy is a sustainable ecosystem of creation. A lonely star, it's the end of the line.
So, these rogue stars, they aren't just cosmic oddities. They're like little glowing fossils. Every single one tells a story of a violent galactic collision, a greedy black hole, or maybe even a story about the very first sparks of light in the universe. By studying these lonely wanderers, we learn about the grand, chaotic, and deeply interconnected history of, well, everything.